So let's run this.
Analog devices like potentiometers have to be polled, whereas digital things like buttons are going to be 1 and 0. You can actually get an event when that happens, but you wouldn't want an event every time the potentiometer actually turned a little bit, or a little bit of noise in the line type stuff affected it. So you have to go and request the value from them.
All right, so we got that started. Now if I start changing the potentiometers, I can get some interesting electronic music going on here. Yeah, exactly. So I just need a little bit of, somebody give me some bass here. All right, very cool. So old school 8-bit music. Actually not even 8-bit.
It's 1 bit.
1-bit music, there you go.
You need to wear the hair when you do that.
I'm not going to wear the hair. There's no chance on this planet I'm going to wear the hair. All right, so putting that aside, let me grab my next amazing trick. All right, this guy I've got E-block suspension on 9. Trick is I got to do a little bit of quick swapping here. Ow! Yeah. Thankfully, most of these things are plug-and-play friendly. Yeah, there we go. All right, so what I'm using here is I'm adding in some infrared and LED and some other good stuff here. So I need here.
If you thought coding on the fly was hard, try wiring a bunch of crap up in front of it.
All right, so in my IR receiver goes pin 7. So pin 7's right there. Thankfully, these only go in one way, although Pete was threatening to shave off the part that makes it only go in one way just to be really annoying. I'm grateful to him that he didn't actually do that.
I thought it would be a good practical joke to swap voltage and ground.
Yeah, that'd be fun. Magic smoke.
Pete,
All right,
question.
Yeah.
Let's say I have a moisture measurement thing or whatever that I can, but I don't want it to be running all the time to say battery or whatever. Can you make the device go to sleep, measure every 24 hours or something?
So I don't know exactly how it's handled underneath, but you can sleep the thread. I don't know if that's in your main thread. I don't know if that puts the processor into a sleep state or anything like that.
It's still using power.
You can definitely do that on the C side of things, but I'm not sure what happens in the microphone.
All right, so what we're going to do here, I have an infrared receiver, E-block. I have an LED E-block for some status information. I have a button E-block, and I have an infrared LED E-block. All those are connected into the same expander module. Now, one of the things that's also nice about here is this is very forgiving. If you have things plugged in that you're not using, it ignores them. Right? So you're not going to necessarily throw your project off by leaving your screen plugged in, for example. Like in this case, I don't have anything going on my screen. So let's run this. Cross my fingers that it works. And have a little fun here.
USB is used only to
I beg your pardon?
USB is used only to deploy the code, or can be.
So USB is what I'm using for both power and debugging and deployment right now.
Okay.
You can also power based on the DC adapter there.
Can we
There's
write
another-
the Windows? Can
There's
we
a
write the
USB,
Windows?
I think I know what you're asking, but there's another, I don't know if you can see it up here at the top. This lets your device be a USB host,
Right.
right? So you can also do other things, and the people are messing around with stuff like Connect.
We didn't see it.
You didn't?
I'm
Oh,
sorry, I didn't want to sit on the board.
So right there,
Okay.
right there is, this is the USB client module. So this is what I was mentioning, you could actually attach a mouse, a keyboard, basically anything you have a driver for, you can use. All right.
Literally, we can write a Windows Forms application or a WPF application and add the events to send signals to it.
Yeah,
Oh,
so-
yes, on the PC you can send,
yeah.
you can do that. If I remember correctly, the regular USB interface, you can communicate with the device at runtime
Yeah.
if you want.
You can also, this has an Ethernet module, so you could do it over Ethernet as well.
So put it on the Wi-Fi in your home project and maybe
Yeah,
send
there's
signals,
right.
turn off the
Wi-Fi.
light from your computer or something.
Yep, or even just plain old wired Ethernet.
So
All
people
right.
have written web servers that run on these.
So what I'm going to do here is, this is basically a poor man's universal remote. So what I've got is a button that when I press the button, the program will be ready to learn an IR code. In this case, I'm going to take an IR code from my radio-controlled helicopter. I'm going to move my board up here a little bit so you can kind of see what's going on here. So I'm going to hold this down. When the red light goes on, it's ready to learn. There we go. And then I give it a signal. Oh, that isn't actually the signal that I wanted, so...
There's a little more danger here than just blue smoke, by the way. Spinning blades.
Okay, so the LED goes off. It says I've learned this particular code. Now what I can do is turn this guy off. So look, Ma, no hands. Turn on our handy dandy helicopter.
Be ready to duck.
Yeah, be ready to duck. It's not going to go far. And now if I do just a short press on the button, it does nothing.
Oh,
There we go. So basically what that was doing was repeating the command that I had
I'll
sent.
hold it for a second.
Okay. Here, you can let it fly. Right, turn around to the emitters towards the back. Ready?
Let me get my fingers out of the way. All right, here we go.
Yeah, you lower it down a little bit. There we go. There you go. So thankfully they're pretty durable. Now, if I had the time to analyze the protocol...
That was very cool, by the way.
Basically, when I capture that, what I'm capturing is a byte array that represents the bytes that are sent from the radio controller to the helicopter. If I capture enough samples, I could analyze that protocol, figure out what it is, and basically program the Gadgeteer to fly this in a pre-programmed pattern. Right now, all I'm doing is basically take off and crash.
Nobody unlock your car.
What's that? Yeah, so minorly entertaining. All right, I got one more demo. I know we're running real short on time, but I want to get to this.
So if you want to use a mouse for that,
What's that?
where would you deploy the driver with the package?
Sure, yeah. So you would basically just reference it like you would any other module.
So maybe you can
package.
plug it in with the little joystick thing, or reverse engineer the protocol that the.
Are you saying, you're saying how would I plug a mouse into that and use that? I mean, you would have to know, or you'd have to learn how the mouse communicates, right? And you would have to replicate that in the MicroFramework, right? So if you just plug the mouse directly.
So what this code is doing here is basically I'm capturing some information from one of the pins, in this case pin 7 or pin 6. I'm basically setting my IR to be my pin capture from the capture pin, and then I have this remote generator is basically using something called output compare. What that will do is take the signal that it received and then combine that with the carrier wave that the remote sends, which is I think 38,000 hertz or something like that, 38,000 cycles, to combine that so that it replicates what this helicopter is expecting. So, quick tour of that code.
Your video stopped up here.
That's all right. That's fine. Thank you, though. It's either out of battery, out of space. It's okay. All right. So last demo, let me make sure I've got all the right things plugged in for that. Network. I have more gadgets and Goo-Gaws than maybe 2 people combined, maybe 3. All right. So I'm going to take advantage of the network module. I've got lights. Good. Okay. Whew. All right. So this is going to use my screen, my network module, and I need camera module and.
There's also, I mentioned the Wi-Fi stuff. There are other
camera module.
There are other standards like something called Zigbee, which is used a lot for remote control over long distance. So it's like a long distance wireless communication. Like some of the versions of that can communicate over miles. So people are creating microcontrollers that sit on like their RC airplanes, and they can go and they can capture video and transmit it down, do all sorts of other stuff with that. You can certainly do that with this as well.
An SD card. So one of the modules that comes with the kit is an SD card module, which is awesome because it allows you to actually store data and retrieve it. And
The SD card is only slightly smaller than a 3.5-inch disc.
yes, but you can't play the Imperial March on an SD card. All right, so let's go ahead and run this, and we'll talk about what it's doing. So basically, this program. So I've got a bunch of modules connected. the idea behind this program was an event-specific device where I can plug in an overlay that's specific to an event. So in this case, we'll be plugging in something for CMAP Code Camp. Snap a picture of someone and send an email to a specified email address that effectively says, wish you were here. Right? So fairly involved. It's not 100% complete. There's still some pieces I need to get put together here. But I'm going to actually stop as soon as I get a chance here. You see where it says deploying assembly? So this is actually a fairly significantly sized program given all the stuff I'm trying to do.
What's the deployment size like you can push? Like what's the hard drive space or whatever, like storage size on it?
Well, so the RAM on the device is 16 megs.
So how much is flash, do you remember?
Gotcha.
A lot smaller than that. I don't recall exactly.
Flash space is usually not that big, it's usually 512K or something like that. I mean, which is relatively large, and programmed computers in the 80s, 512K is huge, right? But,
All right, so I'm going to start this again. Now, in this particular case, I'm using the Glide library for my UI. So I want to show you that real briefly. So Glide basically is very similar to XAML. If you've ever seen XAML, you're going to get Glide right away. One of the advantages that Glide gives you is they provide this designer. There isn't any design view for XAML inside of Visual Studio for the WPF subset that works in .NET MicroFramework. So if you're used to a design surface, you're not going to be very happy with WPF in that environment. It's not hard to do the XAML, but what this allows you to do is, for example, I've dragged out a button onto the page, I've changed the name of the button, or the caption of the button to save and send, and then once I've designed a UI that I'm happy with, I can simply go in here and say window show XML, copy this, and I can copy this and put it into a resource file inside my project, and then load the XML from that file into the window. And I'll show you the code, what that code looks like here in